Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have completed chapter number 7, that is triangles. Hope you have revised well. In today's session, we shall discuss a new chapter, that is chapter number 10, circles. Let's move on to the topic. You can see various pictures and figures on the screen. Did you notice anything common between them? All these figures look similar to a particular shape, that is a circle. For example, the shape of a bangle, shape of a pizza, bicycle wheel, coins, etc. Circles are the most common shape in this universe. In this session, we will learn all the basic terminologies and context to a circle. Circles. There are lot many objects in our life which are round in shape. So, let's take some examples. Clock, dartboard, card wheel, ring, vehicle wheel, coins, etc. So here are some examples. The pictures of some circular shape objects are also shown here. Let's define circles and its related terms. The collection of all the points in a plane which are at a fixed distance from a fixed point in the plane is called a circle. The collection of all the points. Simply we cannot collect the points. There are some properties. The property is they are at a fixed distance from a fixed point. They are at a fixed distance from a fixed point. For example, there is a fixed point and there is a fixed distance also from the collection of points. There are dotted points shown here. If you take any one point from these dotted points and if you measure the distance from this point to this fixed point, that is same for any other point from these dotted points. So when you join these dotted points, we will get a circle. The dotted points property is that they are at a same distance. They are at a fixed distance from this fixed point. So that fixed point is called the center of the circle. Here there is a fixed point is marked. So that point is called the center of the circle, and the fixed distance is called the radius of the circle. Here let's mark all these things. There is a circle. This is a circle, and here there is a fixed point that is in the middle of the circle, that is called the center, and there is a fixed distance, that is AB, means from the center of the circle to a point on the circumference of the circle. That distance, that is AB, is called the radius of the circle. Next, we shall discuss the interior and exterior of a circle. This is quite familiar for us. Interior and exterior. Interior means inside and exterior means outside. That is a simple meaning. So let's define by connecting these two terms with a circle. Here, a circle divides the plane on which it lies into three parts. Whenever a circle comes into the plane is divided into three parts. What are they? Let's check it. Inside the circle, which is also called the interior of the circle. Whenever the circle comes into the plane, it is divided into three parts. The first part is inside the circle, that is this portion. Inside the circle, that is called the interior of the circle. Second one is the circle, means these points, collection of these dotted points, that is the circle. And the third one, outside the circle, which is also called the exterior of the circle. Outside the circle in the sense this portion, outer part of this collection of these dotted points. So the outer portion is called the outside of the circle, that is also called the exterior of the circle. The circle and its interior make up the circular region. Usually the circular region is a term which we are going to use in mensuration, where we'll calculate the area and volume and all. So circular region means this circle and its inside. that is called the circular region. The circle and its interior make up the circular region. And here we need to identify interior and exterior. These two, just we will visualize it. So if you consider a circle, inside the circle is interior of the circle and outside the circle is exterior of the circle. Another important term is circular region. Circular region in the sense the circle and its inside. Not only inside, the circle and its inside makes the circular region. Let's continue terms related to circle. The first one is chord. Any straight line segment whose both endpoints lie on the circle. Consider a circle and the center is marked here. Chord means any line segment whose both endpoints lie on the circle. If you take a line segment and check or observe the endpoints, if it lies on the circumference of the circle, then we can call it as chord of that particular circle. Consider a green line here, and if you observe the endpoints of that particular green line lies on the circumference of the circle. So this green line is called the chord of this circle. And the next one is diameter. The chord which passes through the center of the circle is called the diameter of the circle. Here we have already learned about chord. Chord means a line segment whose endpoints are lying on the circle. The chord which passes through the center. For example, if you consider the red line, it is a chord because both the endpoints of the line is lying on the circle, on the circumference of the circle. And it is also called a diameter because that chord is passing through the center of the circle. So a chord which passes through the center of the circle is called the diameter. The property of diameter is, in a circle, diameter is the longest chord. If you draw any chords within this circle and observe their lengths, diameter will be the longest chord because diameter or that particular line is passing through the center of the circle. So diameter is the longest chord. Next one is arc. A piece of circle between 2 points is called an arc. In a circle, we can have two possible arcs. The bigger one is known as major arc and the smaller one is known as minor arc. A piece of circle between 2 points. Suppose if I consider these line segments and end points, if I take here there is one point and here there is another point, and the length between these 2 points are called the arc. There, whenever these 2 points comes into this circle, the circle is divided into 2 portions. One is above the green line and another one is below the green line. So based on their lengths, we can call it as major arc and minor arc. The bigger one, that is above the green portion, that is called the major arc, and below the green line, that portion is called the minor arc because they are shorter in length. So if you draw a circle separately and if you take 2 points P and Q, this P and Q is dividing the entire circle into 2 parts. One is above PQ and another one is below the points PQ. So above the point PQ, it is in longer in length, and below the portion PQ, that is in shorter when we compare with the upper portion. So the bigger one is called the major arc and the smaller one is called the minor arc. So the upper portion is the major arc and the bottom portion is the minor arc PQ. Next one, circumference of the circle. It is the length of the circle if you open and straightened out to make a line segment. Means if you cut a circle from a particular point and if you open it, you will get a straight line. And the length of that straight line is called the circumference of the circle. That is a standard definition. In simple words, if you say circumference of the circle is the length of the boundary of the circle. The length of the boundary of the circle, that is called the circumference. So here this portion, this entire circular portion, if you measure the length, that is called the circumference of the circle. Segment and sector of the circle. First one is the segment, another one is the sector. Segment of the circle is the region between either of its arcs and a chord. It could be a major or minor segment. When we visualize it, a segment of the circle is the region between either of its arcs and a chord. Either of its arcs. See, when we take 2 points P and Q on the circle, there are 2 arcs are formed. One is the major arc, which is on the top of PQ, and another one is the minor arc, that is the bottom portion. and here segment is the region between the arc and the chord. So this is the chord, and the major arc and the chord, the space between these two is called the major segment. And PQ, here bottom portion is the minor arc, and the minor arc and the chord PQ, when we take the space between these two, the chord PQ and the minor arc, we call it as minor segment. Or in simple language, if we explain, if you consider a circle and PQ as a chord, the chord PQ divides the entire circle into two portions. When we compare the area, which is the bigger area, that is called the major segment, and which is the lesser in area, that is called the minor segment. Next one is sector of the circle. Sector of the circle is the area covered by an arc and two radii joining the center of the circle. It is the area covered by an arc and two radii joining the center of the circle. As before, it could be the major and or minor sector. When we visualize it, there are two radii, OP and OQ. Radius plural is radii. So OP and OQ are the radii, and when we consider P and Q 2 points on the circle, it divides the entire circle into two arcs. One is the major arc, another one is the minor arc. So the space or the area covered between two radii and the minor arc, that is the minor sector, and the area covered by two radii and the major arc, that is called the major sector. The white portion is the major sector, and the blue portion which is shaded, that is minor sector. Next we shall discuss angle subtended by a chord at a point. We have already discussed about chord. Chord means a line segment whose end points lie on the circumference of the circle. Angle subtended by a chord. In a circle, AB is the chord and is making angle ACB at any point of the circle, then this is the angle subtended by the chord AB at a point C. Let's visualize it, then you will get more clarity. There is a circle and a chord AB is given to you, and this chord AB is making an angle with this point C on the circumference of the circle, that is called angle ACB. That is what here it is mentioned. AB is the chord and is making angle ACB at any point on the circle. Then this angle is the angle subtended by the chord AB at a point C. Again, this line segment or this chord AB is making another angle with O, that is the center of the circle, that is angle AOB. Here angle AOB is the angle subtended by the chord AB at point O. Again, this chord AB is making another angle ADB with another point on the circumference of the circle, that is D. So angle ADB is also the angle subtended by AB at a point D on the circle. So through this diagram we are able to identify the angles subtended by a chord at a point. When a diagram is given to you, you must be able to identify the angle subtended by a chord at a point. For that purpose only this diagram is shown. So this AB, chord AB is making angle ACB with C, angle AOB with O, and angle ADB with D. Next we shall discuss some results, and you must go through the results very carefully, and without knowing these results you will not be able to solve any questions from the exercises. So you must take utmost care while listening these results, and I am using the word statements. Statement number 1, 2, 3 like that I am putting. So each one we have to consider as a result or formula that you must go through it very carefully. First result or first statement is equal chords of a circle subtend equal angles at the center. We have already learned about chords. So equal chords means chords which are equal in length of a circle subtend equal angles. how a chord is making an angle in the circle that we have already discussed. So equal chords of a circle subtend equal angles at the center. Let's visualize it. There is a circle and two chords PQ and RS are the two chords because the end points are on the circle. End points P and Q are on the circle, R and S are on the circle. So PQ and RS are two chords. Equal chords means their lengths are equal. So here it is a single cut is marked. They are equal in length. So these chords subtend equal angles at the center. Center is O. So the chord PQ is making an angle POQ with the center, and chord RS making an angle ROS with the center. Once again, chord PQ making an angle POQ with the center, and chord RS making an angle ROS with the center. So let's mark these two angles as angle 1 and angle 2. We have to prove. The proof of this statement is included in the syllabus, so we have to study the proof. So we have to prove angle 1 is equal to angle 2. Here, a circle with the center O and two arcs PQ and RS, such as PQ equal to RS, is given to you. Means two, as I explained to you before, that we are writing in words. That's all. PQ and RS are the two chords with a circle having center O, and the given condition PQ is equal to RS. Then in triangle POQ and SOR, we have to prove the congruency of the two triangles. That is the way. Triangle POQ and triangle SOR we have to take. Then OP is equal to OS. So OP and OS are equal because they are the radii of the same circle. Since the circle is same, this OQ, OS, OR, OP are the radii. So they are equal in length. OP and OS are the radii. So radii of the same circle. Again, OQ is equal to OR. You can see here OQ and this one is OR. OQ and OR are equal because they are the corresponding parts as well. Simply you cannot take any radii. Just to see the triangle. Here OQ and here OR. Radii of the same circle. PQ is equal to SR. That is given condition for us. Equal chords. PQ is equal to SR or RS. So that is given. By using SSS congruency, triangle POQ and triangle SOR congruent, then angle 1 is equal to angle 2 because they are the corresponding parts of the congruent triangles. So since we have proved angle 1 and angle 2 are equal, we can say that equal chords of a circle subtend equal angles at the center. So here this statement also very important, the proof also important, that is included in the syllabus. So the first statement, it is clear for us. The first result, it is clear for us. If the chords are equal, then the angle formed by these chords with the center also will be equal. So equal chords of a circle subtend equal angles at the center. Next we shall discuss perpendicular from the center to a chord. Perpendicular from the center to a chord. So this is statement number 2 and it is result number 2. We have to by heart and we must go through it very carefully. The perpendicular from the center of a circle to any chord bisects the chord. The perpendicular means angle between them is two lines should be 90 degree. From the center of a circle, we know that it is the middle portion of that particular circle. To any chord also we know that two end points of that particular line should be on the circumference of the circle. Bisects the chord means dividing equally. So let's draw the diagram or let's visualize it. There is a circle, center is here, and perpendicular from the center of a circle to any chord. This is a chord. So let's mark it, this one. AC is the chord, O is the center. Then OB is the perpendicular. We are just drawing the perpendicular towards the chord. OB is the perpendicular. Then The perpendicular from the center of the circle to any chord bisects the chord. Bisects the chord in the sense AB must be equal to BC. So if you draw a perpendicular OB from the center O of the circle to the chord, then that perpendicular will bisect the chord. That means AB equal to BC. Here, if angle OBA is equal to 90 degree, OBA 90 degree means it is a perpendicular. OBA 90 degree means AB must be equal to BC. Then the converse of this statement also we have to study. Converse in the sense the reverse order we have to. The line which is drawn from the center of a circle to bisect a chord must be perpendicular to the chord. The line which is drawn from the center of a circle to bisect a chord. For example, there is a circle. You have drawn a line which is drawn from the center of a circle to the chord. Simply a line. Before it was a perpendicular. We are going just to reverse order. So now you are drawing simply a line. But the property of that line is that line drawn from the center of the circle to bisect the chord. It is bisecting this AC. Means AB and BC are equal. Then that line must be perpendicular to the chord. That means the angle should be 90 degree. From where we started, there we have to end. That is what the statement converts. If AB equal to BC, so for you given condition is AB and BC are equal because you are drawing simply a line OB and this OB is bisecting AC. In the sense AB equal to BC. If AB is equal to BC means we can say that angle OBA is equal to 90 degree. So that is a converse. So you have to by heart these statements. That is very important. The perpendicular from the center of a circle to any chord bisect the chord. If you simply draw a perpendicular towards the chord from the center, then that chord will bisect, that line will bisect the chord. Then converse in the sense, if you draw a line from the center to the chord which is bisecting the chord, then that line which you have drawn will be perpendicular to the chord. That means if AB is equal to BC, then angle OBA is equal to 90 degree. Next, circles through 3 points. So how many circles we will be able to draw which is passing through 3 given points? That is what the condition given to you. Before going to this, first let me consider circles through 1 point. How many circles you will be able to draw which is passing through 1 point? It is quite clear that if a point P is given to you, you can draw as many circles you want through this point P. So there are infinitely many circles you can draw which is passing through a single point which is a given point. And next one, if 2 points are given to you, how many circles you will be able to draw passing through these 2 given points? Here also in the diagram there are 2 points P and Q are given to you. Like the previous one, you can draw as many circles you want passing through these 2 points P and Q. There are infinitely many number of circles you can draw passing through P and Q. Now come to our given condition, that is through 3 points. How many circles you will be able to draw through 3 points? For example, if A, B, C are lying in a same line, means if A, B, C are collinear means lying in a same straight line, then if you draw a circle, what will happen is the third point will be either inside the circle or outside the circle. We will not be able to draw a circle which is passing through this A, B and C if A, B, C are lying in a same line. So the third point, 2 point, it will pass through the given 2 points and the third point will be either inside the circle or it will be outside the circle. But if A, B, C are 3 non-collinear points, means if they are not in a straight line, we will be able to draw exactly one. There is one and only one circle passing through 3 given non-collinear points. Non-collinear points in the sense the points which are not lying in the same line. So here A, B and C are not in the same line, and we will be able to draw there is only one circle passing through these three given non-collinear points. Next we shall discuss the next result, that is statement number 3. Two equal chords of a circle are at equal distance from the center. Two equal chords of a circle are at equal distance from the center. Here there is a diagram. Two equal chords. Here AB and CD are the chords because A and B endpoints are on the circle. C and D, here in CD endpoints are on the circle. So AB and CD are two equal chords and they are at equal distance from the center, means center is O. Equal distance from the center in the sense ON and OM are equal. So if AB equal to CD, then OM is equal to ON. OM and ON are the distances from the center. The converse of this one also we have to study, that is statement number 4. Chords at equal distance from the center of a circle are equal in length. Chords at equal distance from the center of a circle are equal in length, means two chords are given to you and they are at an equal distance from the center, means we can say that the chords are equal in length. Reverse order this one, means if OM is equal to ON, means distance from the center is same, then we can say that chords are equal in length. AB is equal to CD. Next we shall discuss angle subtended by an arc of a circle. Arc, we have already learned about arc. Arc means a portion of a circle between 2 points, that is called the arc. Here angle subtended by an arc of a circle. You have to study next statement or result number 5. Equal arcs subtend equal angles at the center. Equal arcs, if the length of the arcs are equal, then that arcs subtend equal angles at the center of the circle. For example, here AB is one arc and CD is another arc. So AB and CD are equal arcs because they are equal in length. Then these AB and CD subtend equal angles at the center, means arc AB subtend angle AOB at the center and arc CD subtend angle COD at the center. So these two blue portions which is marked here angles, they are equal. So angle AOB is equal to angle COD. That is the result. Once again, equal arcs subtend equal angles at the center. Next we shall discuss a very important result, that is statement number 6. Angles in the same segment of a circle are equal. Angles in the same segment, we have already discussed about the segment. Segment in the sense, if you draw a chord on the circle, that chord divides the circle into two portions, that is two arcs we can say. So the space between the major arc and the chord is called the major segment, and the space between the minor arc and the chord is called the minor segment. Suppose there is a circle and I have taken a chord AB and I have considered a point C on the major segment, that is on the upper portion major segment, and this chord AB makes angle ACB with the point C, and again I am taking another point D on the same segment in the sense major segment, and the chord AB makes angle ADB with the point D on the major segment. So these two angles are equal. That is what the result says. That is angle ACB and angle ADB. These two are angles on the same segment. They are equal. So if I mark this one as A and B, the statement says angle A is equal to angle B. Means angle in the same segment of a circle are equal. Next we shall discuss another important result, that is statement number 7. The angle subtended by an arc at the center is twice the angle subtended by the same arc at some other point on the remaining part of the circle. So when you read this statement you may feel it is very difficult, but through a diagram it will be easy for you. So here there is an arc which is darkened here, PQ, arc PQ. So it is mentioned about the angles which is formed by this arc PQ. So this arc PQ makes two angles. One is with the center O and another one is with the point R on the circumference of the circle. One is with the center O and another one is with the point R on the circumference of the circle. The statement says angle at the center, that means this angle is twice the angle at the circumference. Once again, angle at the center is twice the angle at the circumference. For example, if you take this angle as A, angle at the center is twice the angle of this one, means twice, 2 into A. Once again I repeat, so angle at the center is twice the angle at the circumference. If the circumference angle is 30, then the center angle will be 30 into 2, that is 60. So here angle POQ is angle at the center, because center is O, is twice the angle at the circumference, that is 2 into angle at the circumference is PRQ. So you can derive one more formula from here, that is angle PRQ. This portion angle PRQ, if you want to calculate, we can bring this one here, that is 1 by 2. This comes here as a division. So 1 by 2 into angle POQ. Angle PRQ is equal to 1 by 2 into angle POQ. In reverse order, if you say angle PRQ is angle at the circumference. Angle at the circumference is half of the angle at the center. Angle at the circumference is half of the angle at the center. So any one you have to study and you have to derive it the another one. It's not a problem. So easy one is angle at the center is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. So in a statement, if you say the angle subtended by the arc at the center is twice the angle subtended by the same arc at some other point on the remaining part of the circle. Next we shall discuss a new term, that is cyclic quadrilaterals. Quadrilaterals we have already studied in the smaller classes, that is a closed polygon having 4 sides. Cyclic in the sense something related to circles. Here, if all the vertex of a quadrilateral comes on a circle, then it is said to be a cyclic quadrilateral. All the vertex means in a quadrilateral there are 4 vertices are there. If all these 4 vertices are on the circumference of a circle, then it is said to be a cyclic quadrilateral. Let's visualize it. There is a circle and there is a quadrilateral ABCD. When you observe the vertices, vertex A, B, C and D, when you observe, these 4 vertices are on the circle, not inside, not outside. It is on the circle. So once these 4 vertices are on the circle, we can say that ABCD is a cyclic quadrilateral. There is statement number 8 we have to study. The sum of the opposite angles of a cyclic quadrilateral is 180 degree. Sum of opposite angles. Here angle A, if I take, angle C is opposite angle. Angle B, if I take, angle D is the opposite angle. So if the quadrilateral is cyclic, then angle A plus C is 180 degree. Opposite angles are 180 degree. Again angle B plus angle D is also 180 degree. So this is one statement. The converse also we have to study. One statement in the sense given to you cyclic quadrilateral, then we can say opposite angle sum is 180 degree. Next, given to you opposite angles 180 degree, then we can say that it is cyclic quadrilateral. Reverse order. That is a statement number 9. If the pair of opposite angles of a quadrilateral has sum 180 degree, then the quadrilateral will be cyclic. Opposite angles sum is 180 degree means we can say that the quadrilateral is cyclic. Means if angle A plus angle C is 180 and angle B plus angle D 180, if this condition satisfies, then we can say ABCD is a cyclic quadrilateral. Now let's recall all the statements or the results what we have learned so far. The first statement was equal chords of a circle subtend equal angles at the center. Second one, if the angles made by the chords of a circle at the center are equal, then the chords must be equal. Third one, the perpendicular from the center of a circle to any chord bisects the chord. Next one, the line which is drawn from the center of a circle to bisect a chord must be perpendicular to the chord. Next one, there is one and only one circle passing through three given non-collinear points. Next one, two equal chords of a circle are at equal distance from the center. Next one, chords at equal distance from the center of a circle are equal in length. Next one, equal arcs subtend equal angles at the center. Angles in the same segment of a circle are equal. Angle at the center is twice the angle at the circumference. The sum of the opposite angles of a cyclic quadrilateral is 180 degree. If the pair of opposite angles of a quadrilateral has sum of 180 degree, then the quadrilateral will be cyclic. So these are the major statements we have studied, and you have to by heart all these statements. Not only by hearting, you must be able to identify the angles and lengths which is mentioned in the statements. So if you study this one properly, it will be easy for you to use it and solve the exercise questions. Dear students, today we have discussed all the basic concepts from the chapter circles. You must go through all the concepts along with the diagrams, and while revising, if you have any doubt or confusion, please note it and keep. We will discuss it during the online session. Thank you for watching.